I just want to show you guys a quick example how to calculate the part A for our heat of vaporization lab. This is going to be different from your lab. You'll have a different number here. In fact, you'll probably get a range and you'll have to get the average of it, okay? Median value or average, and then you'll have an unknown number. I'm not going to put one here, but here's what I have for an example. So 97.1 Celsius, I can turn it to Kelvin at 273. And then this will be given as my atmospheric pressure. Now, based on this here, if I look up 97.1, and I can see on my list here on page 117, 97 is closest to 1 propanol. So my answer for this would be 1 propanol and 47.5 for the delta H vaporization. Okay, we will use this information to calculate the stuff down here because I know Hvap goes down here. And then P1 is obviously 761.9. And then P2 is what we're looking for. T1 is 370.1 Kelvin. T2 would be this. So in this case, 295. Okay. R is given 8.314. So let's go ahead and put this in. Ln P2 over 761.9 equals to minus. So the Hvap here is in kilojoules and this R is in joules. So the unit here is joules per moles Kelvin, which is why we use Kelvin here. And then we gotta use joules. So I'm gonna turn this into from kilojoules to joules by multiplying by 1,000. So just take 47.5 and I'll just do times 1,000 because I know that's how I can get it to joules. So that's joules per moles. And then my R is 8.314 joules per moles Kelvin. And then 1 over, in this case, 295 Kelvin minus 1 over my T1, which is 370.1 Kelvin. Okay. So all you do now is you plug this into your calculator. Now, when you try this, you should try with my example, see if you can get it. What I like to do is take 1 over 295, get an answer for that, and then hit minus 1 over 370.1, get the answer here, times negative 47.5 times 1,000, and then divide it by 8.314, and I'll get my answer, okay? So I'm gonna do that on my calculator. One over 295, I get an answer, and then minus 1 over my T1, 370.1. Okay, I got an answer for this right here. Then times negative 47.5 times 1,000. And then I divide by 8.31. Actually, I'm pretty sure I made a mistake. Hold on. 1 over 295. All right, got the same answer again. So it's negative 3.93. I'm just gonna round it up, but I'm keeping all my numbers on here, okay? And then let's see. Now, the trick here is what everyone has problem with. To get rid of this ln, you take e to the power on both sides, okay? So I'm gonna cross this off, and you see how my number is still on there? So I'm gonna take e to the that. So on my calculator, my e function is right here. The second function is basically where the ln is. So shift for me, e, and then answer. And I get this number here. I'm gonna write it down. That equals to 0.0196, okay? And I really keep all my numbers on here. I didn't round it on my, I left it on my calculator. But now I know P2 over 761.9 equals to 0.0196. So P2 would be 761.9 times 0.0196, which in this case would give me 14.96 millimeters mercury as my answer. That goes right here. Okay, so I hope that helps with your calculations.